One of my favorite topics is talking about correlation versus causation. So let's just kind of talk, what does this mean? Well, correlation is a statistical measure of the relationship between two variables. And the key here is a relationship. We are talking about whether two things are related. That's it. Is there a relationship? So this most commonly is used in data that follows a linear pattern, right? Lines that go up, down, all around. When you draw a line based off of data, the closer the data points are to the trend line, the stronger the correlation. So if you have a bunch of dots and then you draw the trend line and the dots are all over, this is not so strong. But if we draw a trend line, you know, there's the dots, there's the trend line. This is really strong in terms of the correlation. Maybe a better picture here. So you can see on the left here, we have really strong positive correlation. We know it's positive because the line from left to right is going up, just like slope. If you have a positive slope, then the only type of correlation you could have would be a positive correlation. So it's strong if the dots are really close to the line. It's moderate if the dots are a little bit farther away. In the middle, we can see there's no linear correlation. Those dots are all over the place. There's no way to figure out if there's a relationship between things. This would be like if we graphed shoe size and eye color. Right? There is no relationship to that. They don't look at somebody and say, oh, you have blue eyes. Oh, man, you wear a size 11. No, that is not at all how this works. Right? There's no linear correlation. Dots are everywhere. On the right-hand side, you can see these lines, looking left to right, are heading in the downward direction, and therefore we have negative correlation. So just like slope, if the line has a negative slope, the only type of correlation you could have would be negative. Again, it's strong if the dots are close to the line, moderate if they're a little bit farther away. So what type of correlation does this represent? Well, we know that our slope is negative, so I would say it's definitely negative. Would you say this is strong? Is it moderate? Well, I mean, the majority of these dots are really close. So I'm going to say this is a strong negative correlation. And what does this tell us? It tells us that there is a relationship between the overall course grade or course score and the number of absences. That's all it tells us. A strong correlation says, okay, there is a relationship. That's all we know. What type of correlation does this represent? Well, you can see it goes up, so this would be positive, and the dots are all exactly on the line. Like, this is the strongest positive correlation. This is perfect correlation, if you will, because there's just completely on there. So this would be a strong positive. So correlation is a mathematical relationship, and we do not say that this is causation, right? Causation means one thing caused the other to happen. So in mathematics, two variables can be related without one causing the other. So in this little graphic here, on the left, we're talking about correlation. Things that are related but do not have a cause and effect relationship. Time spent studying and test scores. I know plenty of people over the years who are like, man, I studied for 14 hours and got a D. And then you're like, well, how did you study? Well, I was watching Netflix the whole time. So just because you spend a lot of time studying doesn't mean you're going to do well, because there are other factors like Netflix. Correlation, education, and salary. Right? Just because you have more education does not necessarily mean you're going to earn more money. There might be a relationship, but one does not cause the other. Alcoholism and smoking. Looks like there is a relationship. Generally, the more you drink, the more you smoke. There's a relationship between those. That doesn't mean one causes the other. On the right side, we have a cause and effect. If you take a test, you earn points. This is true. This is true. I guess unless you don't answer anything, then you earn, but you still earn 0 points, right? You earn points. The second one, completing requirements and being certified. Yeah, kind of like earning a degree, right? If you do all the work, you pass all your classes, that's completing the requirements, then you get the degree. Cause and effect. And the last one, alcoholism and cirrhosis of the liver. If you have alcoholism, that can cause cirrhosis of the liver. True. These are all cause and effect. And I'm sure we can think of other examples. One that I remember reading about was people who ate ice cream, ate a lot of ice cream, also got tangled in their bed sheets. So does that mean if you eat ice cream, you're going to get tangled in your bed sheets? No. That is not a cause and effect, but based off data, it does show a relationship. So that's kind of a ridiculous example, but that proves the point that things can be related. We can show that the more ice cream you eat, the more people get tangled in their sheets. It might just be that people who are prone to get tangled in their sheets really like ice cream. I don't know. It just is what it is. But just because there's a relationship does not mean it is a causation. So just remember that correlation does not imply causation. I'm going to say it one more time. Correlation does not imply causation. So just because two things are correlated does not mean that one causes the other.